Welcome to the Meade Training Series. I'm Scott Roberts and I'll be your guide in setting up and using this telescope. This video is to be used with the printed instruction manual that came with the scope. By now you should have read through the first part that covers assembly. Astronomy is about exploration and discovery, and the more you learn about your telescope, the more your understanding of the universe will expand. So let's get started. If you haven't used your Meade telescope yet, I want you to remove the lens cover, drop in an eyepiece, look through it and focus it. There are no rules here that say you have to understand everything about your scope before you use it. The point is that using a telescope should be fun and relaxing. You're supposed to be having a good time. So, turn off the DVD player, go outside and enjoy your Meade telescope. Your telescope may be a slightly different model than those used in this video, but they operate essentially the same as the models presented here. Your telescope comes with the following parts: optical tube. Some models have cradle rings with lock knobs. Aluminum tripod with an accessory tray. Two 1 1/4 inch eyepieces, a 25mm and a 9mm. Some models have a 2 x 1 1/4 inch Barlow lens. A red dot viewfinder with bracket. The refractor models are supplied with a diagonal mirror. Telescope mount. 2 flexible cable controls. 1 or 2 counterweights and a counterweight shaft. Mounting hardware used in the assembly. Some models need to have their mounts unfolded correctly before attaching the tripod legs. They're folded up as shown here in order to ship your telescope components safely and efficiently. If you have another style mount, you won't need to unfold your mount. First, rotate the mount as shown here. The saddle plate should be at the top of the mount and the hole for the counterweight shaft should be pointing down. Move the mount so that the pointer on the latitude adjustment is pointing about halfway between 30 and 60. On the other side of the mount, tighten the latitude adjustment knob. Now you're ready to assemble your tripod. The tripod is the basic support for your telescope. Its height may be adjusted so that you can view comfortably. Line up the holes at the top of one of the leg braces with the holes in the mount. Thread one of the 2-inch bolts through the holes. Thread a washer followed by a wing nut over the bolt and hand tighten to a firm feel. Some models may have bolts instead of a wing nut or other variations. Refer to your instruction manual for details. Attach the remaining 2 legs to the mount in the same manner. Spread the legs apart evenly. Next, attach the accessory tray. The tray helps stabilize the tripod and is also a convenient holder of the eyepieces and other Meade accessories, such as the Barlow lens. There are 2 styles of accessory trays. One style has a triangular tray, and the other one is circular. First, we'll cover the circular tray styles. To attach the brace supports to the tripod, line up the holes at the end of one of the leg brace supports with the holes in one of the leg braces. Thread one of the 1/2 inch bolts through the holes. Thread a hex nut over the end of the bolt. Hand tighten the bolt and hex nut. Repeat with the other 2 leg braces. Thread the tray over the center mounting bolt and tighten to a firm feel. To attach the second style tray, first remove the plastic protector from the tray brace. Place the accessory tray on top of one of the leg brace supports. Slide a mounting screw through the hole at one of the corners of the accessory tray and through the slot in the leg brace support. Thread on a wing nut and tighten to a firm feel. Repeat this procedure until all three corners of the tray are mounted to the three leg braces. Next, set the height of your tripod. Thread in a leg lock knob into each of the tripod legs. Slide the inner portion of the leg in or out to the desired length. Rotate and tighten the leg lock thumb screw to relock the leg lock. Repeat for the other two legs. The optical tube gathers light which is focused at the eyepiece. Your telescope comes in one of two styles that allows you to attach the optical tube to the mount. The larger telescope models, such as the 114EQ, use a cradle ring to attach the tube to the mount. The smaller tubes like the 60EQ model do not. Note the bolts on the optical tube. Remove the thumb screws. Slide the bolts into the slots on the saddle plate. Replace the thumb screws onto the bolts and tighten to a firm feel. If your telescope includes a cradle ring, place the tube into the rings. Close the cradle rings and rotate the lock knob to secure the tube in place. Slide the cradle assembly into the slot of the saddle plate as shown here. Tighten the attachment lock knob to a firm feel. Next, you'll attach the cable controls. First, slide the horizontal cable, also called the RA cable, over the cable shaft. Tighten the thumb screw to a firm feel. Slide the vertical cable, also called the deck cable, over the cable shaft. Tighten the thumb screw to a firm feel. Next, attach the counterweight. Hold the counterweight firmly in one hand and slide it onto the counterweight shaft. If you have a second counterweight, also slide it onto the shaft. Tighten in place using the lock knobs. While holding the unlocked counterweight firmly in one hand, thread the counterweight shaft onto the mount as shown here. Note the safety washer at the end of the shaft. This washer prevents the counterweights from sliding all the way off the shaft. Do not remove this washer from the shaft. Remove the dust cover from the optical tube assembly. Look at the other end of this telescope. Note the 6 screws and the velvet circle. Do not loosen or remove these screws or peel the velvet off. These screws are for collimation. You can refer to the instruction manual for more information about collimating your telescope. In order for these telescopes to move smoothly in all directions, they must be balanced. In order to balance your telescope, first loosen the RA lock and rotate the telescope so that the counterweight shaft is parallel to the ground, as shown here. Slide the counterweight along the shaft until the tube remains in one spot without drifting up or down. Tighten the counterweight lock knob and then retighten the RA lock. If you have a telescope with cradle rings, you'll also need to balance the telescope within the cradle rings themselves. Unlock the deck lock. Loosen the cradle ring lock knob or knobs and slide the optical tube until it neither drifts up or down. Relock the deck lock. Your optical tube is now balanced. Some models are supplied with a red dot viewfinder. A red dot viewfinder projects a red dot in place of the crosshairs to make it easier to line up more precisely with the target. There are 2 thumb screws threaded onto 2 bolts of the optical tube. Remove the thumb screws from the tube. Line up the 2 holes on the red dot viewfinder bracket over the 2 bolts. Slide the bracket over the bolts. Replace the thumb screws onto the bolts and tighten to a firm feel. If you have a reflector model telescope such as the 114EQ model, your focuser assembly is at the front end of the telescope. Slide the MA25mm eyepiece into the draw tube. Tighten the draw tube thumb screw to hold the eyepiece securely. If you have a refractor model telescope such as the 60 EQ model, the focuser assembly is at the back end of the telescope. The refractor models use a diagonal mirror. Slide the diagonal mirror into the focuser draw tube. Tighten the draw tube thumb screw to hold the diagonal mirror securely. The diagonal mirror reflects the light from the optical tube to a comfortable viewing position. Slide the MA25mm eyepiece into the diagonal mirror. Tighten the diagonal mirror thumb screw to hold the eyepiece securely. Changing eyepieces changes the power or magnification of your telescope. Use the high-power 9mm eyepiece to view details when observing the moon and planets. If the image becomes fuzzy, switch back down to a lower power. By the way, you might have noticed something strange when you look through your eyepiece. If you have a refractor-style telescope, the image is right side up, but it's reversed right for left. This is completely normal. That means reading words could be a problem, but it has no effect on astronomical objects. If you want to have a fully corrected image, check out Meade's optional erecting prism. If you have a reflector-style telescope, the image is upside down and reversed right for left. Don't panic. All reflecting telescopes present an upside-down and reversed image. These telescopes are designed solely for astronomical viewing, and no erecting prism is available to correct their images. However, astronomical images will look just fine. You can also change magnification by using a Barlow lens. The typical Barlow lens used with your telescope model doubles the power of your telescope. To use a Barlow lens, remove the eyepiece and slide in the Barlow. Slide the eyepiece into the Barlow. Tighten the thumb screws to secure the Barlow lens and the eyepiece in place. Your telescope may or may not include a Barlow lens as a standard accessory. If not, you can obtain a 2x Barlow lens by contacting your Meade dealer. Perform the first part of this procedure during the daytime and the last step at night. Point the telescope at an easy-to-find land object such as the top of a telephone pole or a distant mountain or tower. Look through the red dot viewfinder. Turn one or both of the red dot viewfinder's alignment screws until the red dot is precisely over the same object as centered in the eyepiece. Check this alignment at night on a celestial object such as the moon or a bright star, and use the red dot viewfinder's alignment screws to make any necessary adjustments. There are several different movements that the mount can make. However, to make movements, you'll need to release the locks on each axis. You can unlock the deck lock, and your telescope will move freely on the deck or declination axis as shown here. If you lock the deck lock, you can move your telescope using the deck flexible cable control. You can unlock the RA lock, and your telescope will move freely on the RA, or right ascension axis as shown here. If you lock the RA lock, you can move your telescope using the RA flexible cable control. You can unlock the azimuth lock and your telescope will move freely on another axis as shown here. Practice moving your telescope in all directions and you'll become an expert on how it moves in no time. It should be made clear that before you use your telescope that it must never be pointed at or near the sun at any time. Observing the sun, even for the smallest fraction of a second, will result in instant and irreversible eye damage, as well as physical damage to the telescope itself. Make sure you practice focusing during the daytime. It's a lot easier to become familiar with your telescope when it's light out. Pick out various objects, trees, buildings, signs, light poles, and so forth, and practice focusing the telescope on each object. See if you can bring the objects into sharp focus. Relax and take your time when you observe. Pay attention to the details. The more you observe, the better your eyes will get at picking out smaller and more difficult to see details. Now you'll take your telescope outside for the first time at night. When astronomers observe through a telescope for the first time, they say the telescope receives first light. Let your eye get accustomed to the dark. This may take several minutes. The moon is an excellent object to observe at first. Pick a night when the moon is at a crescent. No shadows are seen during a full moon, making it appear flat and uninteresting. Look for different features on the moon. The most obvious features are craters. In fact, you can see craters within craters. Some craters have bright lines about them. These are called rays and are the result of material thrown out of the crater when it was struck by a colliding object. The dark areas of the moon are called maria and are composed of lava from a period when the moon still had volcanic activity. You can also see mountain ranges and fault lines. Objects in the sky appear to revolve around the celestial pole. Actually, the Earth is rotating, and our movement makes celestial objects appear to move. By lining up the telescope's polar axis with the north celestial pole, or for observers in the Earth's southern hemisphere with the south celestial pole, astronomical objects may be followed or tracked by moving around one axis, the polar axis. This is often called polar alignment. To polar align your telescope, begin by loosening the azimuth lock so the entire telescope with mounting may be rotated in a horizontal direction. Locate Polaris, the North Star, to find north. The two front stars of the Big Dipper point to Polaris. Set the RA axis. Rotate the telescope until the polar axis points to Polaris. The polar axis is described by the arrow shown here. Relock the AS-lock. Level the base of the mount if necessary by adjusting the heights of the three tripod legs. Next, set the deck axis. The deck axis is independent of the RA or polar axis and may not be lined up with the polar axis. To line up this axis with the polar axis, first loosen the deck lock. Then move the optical tube until it points in the same direction as the polar axis. Retighten the deck lock. If your model has a deck setting circle that looks like this, you can easily set the deck axis by unlocking the deck lock and moving the tube until the pointer points to 90 degrees. Retighten the deck lock. Next, set the latitude. Look up the latitude of your observing location on a road map or atlas. Release the latitude lock and tilt the telescope mount with the latitude adjustment knob so that the latitude adjustment control points to your latitude. In this example, we are setting the latitude to 39 degrees. Retighten the latitude lock. Without moving the telescope on the right ascension and declination axes, loosen the azimuth and latitude locks and adjust the telescope until Polaris is centered in the red dot viewfinder. Your telescope is now polar aligned. Once polar aligned, the telescope can track accurately by slowly turning the telescope's RA flexible cable control. To locate and center an object in the eyepiece, loosen the telescope's RA lock and deck lock. The telescope can now turn freely on its axes. Use the aligned red dot viewfinder to locate an object you wish to observe. When the object is centered in the red dot, retighten the RA and deck locks. One of the most popular accessories Meade offers is a selection of eyepieces that range from low to high power. You'll want to select a 1 1/4 inch eyepiece that not only gives you the magnification that you want, but also the eye relief that you need. Other qualities to look for in eyepieces are the apparent field size, which is how large the true field of view will be in the eyepiece, and coatings, which increase contrast in an image. Meade's Series 4000 incorporates all the features that you'd want in a set of high-quality eyepieces. In addition to eyepieces, Meade also offers the number 126 Barlow lens. This can double the magnification of any eyepiece. Not only is this an economical way of doubling the power of your eyepieces, but if you do require a long eye relief in an eyepiece, as in the case of people with eyeglasses, you're going to want an eyepiece that has at least 18 millimeters of eye relief. When you use a Barlow lens, you don't sacrifice any of the eye relief in a long eye relief eyepiece. You just get higher magnification. Meade also offers a full range of photovisual filters. Our Series 4000 color filters helps bring out many details and contrast features of lunar and planetary objects. A neutral density filter is ideal for observing the moon. The 90-degree diagonal results in upright but reverse viewing of land objects. Meade's number 928 45-degree erecting prism orients the image correctly and provides a comfortable 45-degree viewing angle. Contact your local Meade dealer or see the Meade General Catalog for complete details on these or other accessories. The RB60 is very similar to and operates the same as the 60AZA. The assembly is a little different than the 60AZA, but it's very easy to assemble and it has different slow motion controls. The tripod is the basic support of your telescope. Adjust the height of the tripod so that you can view comfortably. Unlock the leg lock. Slide the leg in or out to the desired length. Tighten the leg lock to secure the leg in place. Repeat for the other two legs. Next, spread the legs out evenly apart. The tray helps stabilize the tripod. Place the accessory tray over the center hub of the leg brace supports. Rotate the tray until the corners of the tray click into place. The tray is also a convenient holder of the eyepieces and other Meade accessories such as the Barlow lens. Slide the center post of the mount into the center hole on top of the tripod. Tighten the leg lock knob underneath the top of the tripod to a firm feel. Notice that the lock knob is already attached to the tripod. The optical tube gathers distant light which is focused in the eyepiece. Remove the two lock knobs from the optical tube. Slide the two bolts through the holes in the mounting bracket. Thread a lock knob onto each of the mounting screws and tighten to a firm feel. It can be difficult locating objects in the sky using the eyepiece alone. The red dot viewfinder has a red dot bullseye to help you more easily locate and line up with a celestial target. Slide the red dot viewfinder into the mounting bracket until it clicks into place. To detach from the bracket, press down on the quick release button and slide the bracket out. The diagonal mirror reflects light from the optical tube to a more comfortable viewing position for the eyepiece. Slide the diagonal mirror into the focuser draw tube. Tighten the draw tube thumb screw to hold the diagonal mirror securely. Slide the 25mm eyepiece into the diagonal mirror. Tighten the diagonal mirror thumb screw to hold the eyepiece securely. To move the telescope from side to side, first unlock the horizontal lock. Then rotate the horizontal slow motion control wheel to move the telescope from side to side. To move the telescope up and down, unlock the vertical lock. Then rotate the vertical control wheel to move the telescope up or down.